Hi, I am Clint Cole and this is my performance task in physics. Circuit number 1, the given are all resistors are 4K ohms, 120 volts, 60 Hz, 20 Henry, and 1.5 microfarad. First, we're going to compute for XL and XC. XL is equals to 2 pi FL wherein F is equals to 60 Hz and L is equals to 20 Henry. So we have 2 pi 60 times 20 is equals to J, 7,539.822. Next is for XC. XC is equals to 1 over 1 pi FC wherein C is equals to 1.5 microfarad. Microfarad is equals to times 10 raised to negative 6. So we have 1 over 1 pi times 1.5 times 10 raised up to negative 6 is equals to J, 1,768.388. Now, since we have a Y structure, we're going to get the delta. We're going to name this as RA, RB, and RC. Delta is taken by pair over opposite. But since they're all 4K ohms, so the formula will be like this. So 4K times 4K plus 4K times 4K plus 4K times 4K over 4K is equals to 12K ohms. 12K ohms will be the value of all of our sides. 12, 12K, 12K, and 12K. Since 12K is parallel to 4K, we're going to use the parallel formula here. 12K times 4K over 12K plus 4K is equals to 3K ohms. So 3K will be the new value of each side. 3K, 3K, and 3K. Since 3K is still parallel to 4K, we're going to use this parallel formula. So 3K times 4K over 3K plus 4K is equals to 1,714.286 ohms. So that will be the new value in each this side. Since they are in series, we're going to use the series formula for this. So we're going to add them both. So 1,714.286 plus 1,714.286 is equals to 3,428.572. So 3,428.572 ohms is parallel to 3K in this side. So we're going to use the parallel formula. So 3K times 3,428.572 over 3K plus 3,428.572 is equals to 1,600 ohms. 106,000 ohms will be the value of our ZR. To compute for Z, we're going to need our ZR plus XL minus XC. First, we're going to minus XL and XC. So we're going to have J 5,771,434. They have different units. They can't be solved together. So we're going to use polar to find our Z total and our angle. So polar 1,600 and 5,771.434. J total is equals to 5,989.111 for our angle 74.51. AI is our target solution. So to get AI, we're going to need 120 volts, which is given, and zero angle since there are no given angle, over our Z total and angle from the polar. To get our final answer, we're going to divide our volts and Z total and going to minus our angle. So 120 volts divided by 5,989.111 is equals to 0.02 ampere, and 0 minus 74.51 is negative 74.51. For our next problem, our given is all resistors are 12K ohms, 120 volts, 60 hertz, 4 Henry, 0.5 microfarad. Since this problem is pretty similar to our circuit 1, we're going to solve for XL and XC first again. So XL 2 pi FL is equals to 2 pi 60 times 40 is equals to J 1507.964 and XC 1 over 2 pi FC. So we have 1 over 2 pi 60 times 0.5 times 10 raised up to negative 6 is equals to J 5,305.165. Since we have our Y structure, we're going to compute for our delta. Here is our delta. So we're going to name our delta RA, RB, and RC. So delta is taken by pair over opposite. Since they're all 12K, the formula will be, the solution will be 12K times 12K plus 12K times 12K plus 12K times 12K over 12K is equals to 36,000 ohms. That will be the value of each side. 36K, 36K and 36K. So all of the sides is parallel to 12K ohms. Parallel, and parallel. We're going to use parallel formulas. 12K times 36K over 12K plus 36K is equals to 9K ohms. So 9K will be the new value of each side. So 9K, 9K, and 9K. Since 9K is also parallel to 12K, since 9K is parallel to 12K, we're going to compute 9K times 12K over 9K plus 12K is equals to 5,142.857 ohms. Since they are in series, we're going to compute, we're going to add them together. So 5,142.857 plus 5,142.857 is equals to 10,285.714 ohms. So 10,285.714 ohms is parallel to 9K. We're going to compute for this parallel formula. So 9K times 10,285.714 over 9,000 plus 10,285.714 is equals to 4,799.991 ohms. This will be the value of our ZR. So to compute for ZR plus XL minus XC. Since XL and XC have the same unit, we're going to minus them first. We're going to solve them first. So XL minus XC is equals to 3,787.201. They are not the same unit. We're going to use polar to solve for Z total and for our angle. So polar 4,799.991 and negative 3,797.201. So the answer will be for our Z total 6,120.347, and for our angle is negative 38.300. To compute for our AI, 120 volts is given and no given angle over our Z total 6,120.347 and our angle negative 38.347. First, we're going to divide our volts and CT. So 120 volts divided by 6,120.347 is equals to 0.02 ampere. And for the angle, we're going to minus them. So 0 minus negative 38.347 is equals to 38.347. In circuit number 3, we have 12 volts. R1 is equals to 2 ohms. R1 is equals to 2 ohms. R2 is equals to 12 ohms. R3 is equals to 6 ohms. R4 is equals to 9 ohms. R5 is equals to 12 ohms. R6 is equals to 18 ohms. As you can see, we have our delta. So we're going to put for our Y structure. Naming them RW, RX, and our RY. To compute for our RX, we're going to get both sides. So our R2 and R3. So R2 is equals to 12 ohms and R3 is equals to 6 ohms. So 12 times 6 over to the value of R2, R3, and R4, 12 plus 6 plus 9, we're going to have 2.667 for our W. Going to get the sides. So we have R2 and R4, 12 and 9 over all of the sides. So we have 12 times 9 over 12 plus 6 plus 9 is equals to 4. And our RY, going to get R4 and R3. We have 9 times 6 over all of the sides. 12 plus 6 plus 9 is equals to 2. Since R5 is in series with our RW, and R6 is in series with RY, we're going to add them. So our RW is equals to 4. 4 plus 12 is equals to 16. And our RY, 2 plus 18 is equals to 20. Since they are in parallel with each other, we're going to compute. So 16 times 20 over 16 plus 20 is equals to 8.889. To get our R total, we're going to need our RX, R1, And the last one that we have solved. So 2 2.667 plus 2 plus 8.889 is equals to 13.556. To get our AI, to get our AI, we we need to solve for 12 volts, which is given 12 volts, and our R over our R total. So 12 volts over 13.556 is equals to 0.885. To get our I2, I3, I5, and I6, we need our IA, IA. This is our IA, 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 and IA times, times, times this. To solve this, so I2, R2 is the opposite of I3 is equals to 6 ohms. So 6 is will be our numerator over 12 and 6. 12 and 6 is equals to 0.295. Then for our I3, the opposite of R2 is equals to 12. 12 will be our numerator over 12 and 6. 12 and 6 is equals to 0.59. For our I5, R5, opposite of R6 is equals to 18. So 18 will be our numerator over 12 and 18. So 18 over 12 plus 18 is equals to 0.531. And for our I6, 12, 12, 12 over 12 plus 18 is equals to 354. To get our I4, we will get the side that have a positive discrepancy. So discrepancy is when they are minus, the difference or the answer is positive. So we have I2 and I5 and I3 for R6. So I3 minus I6 is equals to 0.59 minus 0.354 is equals to 0.236. So to check the answer, we will add the answer to I2, then the answer will be I5. Next, for our circuit number 4, we have 250 volts. R1 is 10k ohms. R2 is 10k ohms. R3 is 15k ohms. R4 is 5k ohms. R5 is 12k ohms. And R6 is 20k ohms. This problem is pretty similar to our circuit number 3. So as you can see, we have our delta. Delta. Again, we're going to put our Y structure. So our W, Rx, and our Ry. Again, to solve for our Rx, 15 and 10, and all of the sides. So 15K ohms, 15K times 10K over 15K, 10K, and plus 5K is equals to 5K. Ry, Ry, 15, 15K times 5K over 15, 15K plus 10K plus 2,500 for our RW, 5K times 10K over 15K plus 10K plus 5K is equals to 1,666.667. 1,666.67 plus 12K is equals to 13,666.667, and our RY and R6, 2,500 plus 20,000 is equals to 22,500. So, since they are parallel to each other, we're going to solve for this. So, 13,666.667 times 22,500 over 13,666.667 plus 22,500 is equals to 8,502.304. So to get our R total, we need our Rx and the value of the last computation and our R1. So 5,000 plus 8,502.304 plus 10,000 is equals to 23,502.304. So to get our IA, we have 120 volts, and our RT 23,502.304 is equals to 0.011. So to solve for our I2, I3, and I5 and I6, we need our IA, 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 and like earlier, the our I2 is equals to R2. So the opposite side is R3. So 15K will be our numerator. For our denominator, we're going to add R2 and R3, 15K plus 10K. So it will be equal to 0.0066. And for I3, the opposite is R2. So 10K will be the numerator. 10K will be the numerator. And for our denominator is R2 and R3. So 15K plus 10K is equals, so 10K over 15K plus 10K is equals to 0.0044. Next, for our I5, I5 is the opposite of R6. So 12K will be the numerator, and for our denominator, R5 and our R6, 20K plus 12K. So 12, so 20K over 20K plus 12K is equal to 0.0069. And for our I6 is opposite of R5. So 12K will be the numerator. 12K will be the numerator. And again, 12K over 20K plus 12K is equals to 0.0041. To get our I4, we will get the side that have a positive discrepancy. Positive discrepancy is when they are minus, the difference or the answer is the positive. So we have I2 and I5 and R3 and I3 and I6. So I3 minus I6 is equals to 0.0044 minus 0.0041 is equals to 0.003. To check the answer will be added to our I2, and the answer will be I5. So that's all. Thank you for listening.